All right, guys, welcome to Unit 9, where we are going to look at circumference, arc length, area, and area of sectors. Okay, circumference. Remember, the circumference is the distance around the circle. It is that length that goes around the edge. Our formula for circumference is 2 pi r, or pi times diameter. Remember, we can rewrite these. You can write your circumference as pi times 2r as well. And thinking about that 2r as one amount, it will help when you're solving problems later on. Now we're going to be reporting in two types of answers. We've got our rounded, where you use the pi button in your calculator, and then you'll use your toggle button in order to get to an estimate. You'll have a decimal value that you'll round. You will also be reporting answers in the exact form, which means pi will be in your answer, such as it might be 6 pi units. This would be exact. Okay, so find the exact circumference. We've got circumference equals 2 pi radius. If our radius is 14, circumference equals 2 pi times 14. We're going to put this exactly in the calculator. If our diameter is pi times diameter. Now if we want to look at finding to the nearest tenth, we're going to have 2 pi times 14.3. So our circumference would equal, here it's going to be 89.8 millimeters for to the nearest tenth, and here we'd have 103.7 yards. Make sure you use your units. Pi times diameter, and 2 times pi times radius. Remember, 2r equals the diameter. Now, arc length is a little different than what we have been doing. This is the distance along the curved line. It is not a degree. We're not measuring the degree of curvature. We're measuring the distance from one point to the other on the arc. It is a part of the circumference. And that's why we get our formula. If you look at the formula, this 2 pi r right here, that equals your circumference. This theta right here is your central angle. It's the angle that actually cuts the arc. And then this is your whole circle. Because the arc is a proportional piece of the whole circle. Let's look at using the formula. Here's our formula. Here's our circle. First of all, we've got to think about what is our theta. It's a central angle, so that's going to be equal to the arc that it captures. So now we're just going to plug in our values. 2 times pi times our radius times theta divided by 360. You can enter that all into your calculator. And your arc length is 9.77 meters because we're rounding to the nearest hundredths. Okay, now it says find the exact arc length. So our answer has to have pi in it. So here's my central angle already labeled for me. This is the arc I'm looking for the length of. I'm going to put this into the formula. So I'm going to have 2 pi times my radius of 5 times my 120 degrees, my theta, all divided by 360. Enter it into the calculator. Oops. And that last answer would have been, let's see if I can go back. Here we go. So now again, we would have 2 times pi times our radius times theta divided by 360. Enter it into the calculator, and you're not going to toggle. It's going to give you the answer of 10/3 pi, and we are in inches. Okay, let's take a look at another problem. What happens to the arc length if the radius were to be doubled or halved? Okay, well, let's take a look at this problem again and think about doubling our radius or halving our radius. So our double radius would equal 10 inches, and halved radius would equal 2.5 inches. Okay, so now let's think about, remember what our original was 10/3 pi inches, and let's think about doubled and halved. See how the numerator doubled and the numerator halved from our original, because they are proportional. Okay, let's do a couple of perimeter problems where we're putting this into use. It says find the perimeter of the region. They're talking about this shaded region here. Well, we know from point of tangency to point of tangency, that's 15. It'll be the same on the other side because they're marked as congruent. So I know this is 15. Now I know that this right here is 9, and that equals my diameter. Okay, so I know circumference equals pi times diameter. Now when I think about this, this is going to be half of the circle, and this is going to be the other half of the circle. So I really do need a whole circumference. So my perimeter would equal my 15 plus my 15 plus my pi times diameter, which is 9 pi. That equals my circumference. When you simplify, perimeter equals 9 pi plus 30, and I'm just going to say units. Doesn't give me which unit to use. Okay, let's take another look. Another example where we can use arc length for a word problem. How far does the skater go from the top of one ramp to the top of the other ramp? Okay, well, first of all, I know that he's going to travel this 20 feet. That part is clear. But now I got to think about, okay, what part of the circle is he traveling? Well, when I look at this, I think, okay, if it's from, this is my center of my circle to the edge of my circle, that makes my radius equal to 10. Now, this is a right angle, so my theta equals 90. So I can think about arc length equals 2 pi times my radius times theta divided by 360. When I put this in the calculator, it equals exactly 5 pi. So I'm thinking about, okay, how far does he go? He's going to go 5 pi on this circle, this arc length. He's going to hit the 20, and then he's going to travel another 5 pi on this side. So he will travel 20 plus 5 pi plus 5 pi, and that's going to be 10 pi plus 20 feet exactly. Or if I want to put it as an estimate and I toggle, if I go to the hundredths place, I get 51.42 feet. There you go. That's what we have for finding your arc length. Remember, it is just a formula. This is all formula work. Arc length equals 2 pi r, that is your circumference, times theta divided by 360. We can manipulate this formula. You could, if you were looking for r, if you knew the the angle, your theta, and you knew what your arc length was, you could multiply times 360, and then you could divide by 2 pi theta, whatever that value is, on both sides to isolate r. We'll have some problems like this in your practice work for you where you can manipulate the formula a little bit more. All right, if you have any questions or anything, please hit me up through It's Learning. And the next lesson, we're going to look at the area of the sector.